Okay, let's get started with section 4.3, quadratic functions and their properties. This will be the last section on the chapter 2 test. We're putting this in there with chapter 2 because we're talking about graphs here, so we're putting all the graphs together for the chapter 2 test. So here's our quadratic function, ax squared plus bx plus c. As long as your degree is 2, we're going to have a quadratic function. You must have an a. If you don't have a b or a c, it's still going to be a quadratic function. One small thing on here, the domain of quadratics, always all real numbers. So we'll get into that in a little bit, but something to remember. Okay, let's graph this using transformations. So just quickly, take a quick look. A y equals x squared graph right here. If that was in the middle, this one here, then if we changed our a to a 3, we'd get slightly skinnier. And if we changed it to a fraction, 1/2, we'd get wider. So fractions are a little bit fatter. Same thing if we have a negative in front. Okay, the half is going to be the wider one, and the 3 is going to be the more narrow one, compared with just our negative x squared graph. All right, two things we're going to talk about a lot in this section, the axis of symmetry. That's the line that creates symmetry on our quadratic. Points with the same y values will be symmetric across the quadratic, across that line of symmetry. And your vertex is either your highest or your lowest point, depending on whether we open up or whether we open down. All right, so let's use our graphing calculators first and see if we can't find our vertex and axis of symmetry. I'm going to grab our graphing calculator and plug in negative 2x squared plus 6x plus 2. And we'll go ahead and graph this. Nice standard graph here, negative 10 to 10. All right, so we have a vertex up here. We are opening down. We know that because of the negative 2. Let's go ahead and find what that vertex is. We're going to calculate that. So second trace, calculate up here. Now we don't have a vertex function here, but we do have a minimum and a maximum option. And since we're pointing down, this graph has a maximum. So what is it? Left bound. We'll go to the right of it to create a right bound. And then we'll go up to the very top and guess. And there it is. Your calculator rounds off a little bit, but it's 1.5 and 6.5. So that's going to be our vertex. Our vertex is 1.5, comma 6.5. And then the axis of symmetry is just going to be x equals the x value. X equals 1.5. All right, knowing that, go ahead and try problem 21. Okay, if we have standard form for a quadratic, we can also move this around into vertex form here. And our vertex is going to be at h, comma, k. That's going to be your vertex. A, x minus h squared plus k. And notice that it's always minus whatever your h value is. So if it was plus 3 in here, your vertex would be at negative 3, the opposite. But if it was at plus 5 for the k would just be 5. All right, we're going to need this formula a lot. H is negative b over 2a. This one is useful. You can go straight to your k just from that equation right there, 4ac minus b squared over 4a. Get both of them in your notes, but this one right here is the one that you're definitely going to want to memorize. Negative b over 2a equals h. Because with that, we can identify our vertex. And from that, we can get our axis of symmetry without having to graph. Your vertex is always going to be at negative b over 2a. And then if we take that number and we plug it in for x, we'll be able to figure out the y value. All right, so let's try that here. We have negative b over 2a. Negative 12 over 6 is negative 2. Let's go ahead and plug that back in. We're going to have 3 times negative 2 squared plus 12 times negative 2 minus 5. That is 3 times 4, which is 12, minus 24 minus 5. That's negative 17. So our vertex is at negative 2, comma negative 17. Your axis of symmetry is x equals negative 2. And because we had a positive to start here, we're going to open up. All right, let's move on to seeing if we can take that information and actually graph without using the graphing calculators. So just a quick thing here, remember that the discriminant will tell you how many real solutions you have. This is the part of the quadratic equation under the square root. If the discriminant is positive, we have 2 real x-intercepts. If we're equal to 0, we have 1. And if we're less than 0, we have no real solutions, so no x-intercepts. There it is graphically. If our discriminant is positive, we would have 2 x-intercepts, equal to 0, 1, and less than 0, we don't have any at all. Doesn't cross that x-axis. All right, let's try this. We're going to do 3 of them here, all slightly different. So, graph x squared plus 4x plus 4. Let's find the vertex first. So we're going to say negative b, negative 4 over 2a. So we've got negative 4 over 2. So we've got negative 2. Plug it back in, negative 2 squared plus 4 times negative 2 plus 4, which is 4 minus 8 plus 4, and that gets us back to 0. So our vertex is at negative 2 comma 0. Our axis of symmetry is x equals negative 2, and we are opening up. Okay. We're also going to want to add in the y and the x-intercept. So we're going to start with the y-intercept because that's the easier one to find. The y-intercept is what happens if x is 0. If x is 0 and x is 0, the y-intercept is 4. And then our x-intercepts in this one, not too bad. If we make y 0, 0 equals x squared plus 4x plus 4. This factors to x plus 2 squared. So x is going to be negative 2. That's your x-intercept. Let's go ahead and graph this thing. The vertex is also the x-intercept. That makes sense since the vertex is at negative 2, 0. We're on the axis. We're opening up. We have a y-intercept of 4. We have an axis of symmetry at x equals negative 2. And that axis of symmetry is very helpful because of this point here. If we are 2 to the right of your axis of symmetry, we have to have another point 2 to the left at the same height of your axis of symmetry. We can connect our graph, and we are in business. All right, let me erase our calculations here because we still need to figure out the domain range and where we're increasing and decreasing. All right, so the domain is the easy one. For quadratics, it's all real numbers. For the range, we're looking at this graph. Where's the lowest point you can find? It's at y equals 0, and we're always going up from there. So the range is going to be y is greater than or equal to 0. Where is our function decreasing? As we move along here, we are going down until we hit the vertex. So our function is decreasing from negative infinity all the way until we hit our vertex at negative 2. And then we're going to turn around and we're going to grow. So from negative 2 to infinity, our y values are increasing. All right, so that's the first option. Let's take a look at a slightly more complicated one. We've got negative x squared plus 4x plus 7. Going to find our vertex first, negative b over 2a, which is negative 4 over negative 2, which is 2. Plug it back in, negative, we're just squaring the 2, be careful here. 4 times 2 plus 7 is negative 4 plus 8 plus 7, which is 15 minus 4 is 11. So vertex at 2 comma 11. Axis at x equals 2, and we're going to open down. Okay, y-intercept here. The y-intercept is at 7. And our x-intercept, we're going to have to use the quadratic here. This is going to be negative 4 plus or minus 16 minus 4a c all over 2a. All right. Now I plugged this into my calculator. You guys can do this step as well, but if you plug this into your graphing calculator or just a calculator, you're going to end up with negative 1.32 and 5.32 as your x-intercepts. So now we've got everything we need to graph this. We're going to find our vertex first, 2, 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've got our y-intercept at 7, 1, 2, 3, 4, 5, 6, 7. We've got our axis of symmetry, which means we must have another point here. And we know we're going to cross at negative 1.32 and at 5.32, so approximately there and there. And there we've got a beautiful quadratic equation. Our domain is all real. Our range is y is less than or equal to 11, the highest point. We are increasing from negative infinity to 2. We are decreasing from 2 to infinity. All right, last one like this that we're going to try. And on this one, I'm not going to walk through all of the points, but I just want to introduce the concept of completing the square here. So f of x equals, I'm going to pull the 3 out here and make this x squared plus 4x, and then leave the 5 all by itself over here. I'm not going to touch that. Let's complete the square. What's half of 4? 2. And if we square that, we get 4. So plus 4 would complete the square. But we didn't just add 4, we added 12 here. 3 times 4. How do we cancel out plus 4? Minus 4 times the 3 is minus 12. If we complete this square, this is 3x plus 2 squared minus 17. And so what we have here is we have ourselves a vertex at negative 2. Remember, the opposite of this one, comma negative 17. All right, so we could graph this. I'm not going to have the x-intercepts in here. Negative 2, negative 17, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is down here. And we have a y-intercept at negative 5. 1, 2, 3, 4, 5. Axis of symmetry. We're going to have another point here. And we could figure out the x-intercepts, but in the interest of time, we're just going to use 3 points to graph that. So we're opening up. We have a domain of all real. We have a range of y is greater than or equal to negative 17. Our graph is increasing from negative 2 to infinity. Our graph is decreasing from negative infinity to negative 2. All right. There in the book is a nice shortcut on how to do all the steps if you need some help. Use that in the examples we've done. Pause the video. You have 3 to try. Try 29, 35, and 39. Okay, a couple last things here. We're going to talk about, can we come up with an equation if we're given a point and a vertex? And so we're going to use our ax minus h squared plus k form here. So let me write that form out first. Now f of x is the same as y equals a x minus h squared plus k. Let's go ahead and plug in some points. Our job is to figure out what a is. We have a y number, negative 1. And that's going to match up with, since it's the y-intercept, that's actually 0, negative 1. So 0 minus negative 2, so plus 2, plus negative 5, so minus 5. And so we'll have negative 1 equals 2a minus 5. So 4 equals 2a. So 2 equals a. And we'll go ahead and rewrite this. Y equals 2x plus 2 minus 5. That's your equation. So use the vertex and a point to solve for a, and then rewrite it with the entire equation. Try problem 43. Okay, last thing to do here, we're going to find the maximum or the minimum, and so that's going to be at our vertex, and the max or minimum value is the y value. So here, let's figure out whether this has a max or a min. It's opening down, so this has a max. Let's find out what it is. Negative b over 2a is negative 4 over negative 2, which is 2. Got to plug that back in. Negative 2 squared plus 4 times 2 plus 5. We've got negative 4 plus 8 plus 5. Let's see, that's 4 plus 5, that's 9. So our vertex is at 2, 9. The max is 9. Alright, so you're saying the y value for the max or the min. Alright, that's it. Try problem 51. Your job here is done. Any questions, we'll go over it in class. Good luck.